Chapter 6, dealing with rational expressions, is just a fancy way of saying we're dealing with fractions here. Now most of us, when we go to cancel this 5 over 10, we want to say, oh, cancel those and make a 1 and a 2. However, I'd like to focus on what we're really doing. When we're factoring this 5 over 10, we're saying, or reducing it, we're saying what is a common factor of both the numerator and denominator that I can divide out. And we say internally, 5 goes into each of those, and dividing both the numerator and denominator by 5 gives us 1 in the numerator and 2 in the denominator. That's a key issue here because we're going to be dealing with algebraic expressions instead of numbers, and we need to know what we're dealing with. Likewise, in this next problem, what goes into both the numerator and the denominator? Well, it turns out that we can divide each by 8. We can also divide by a squared and b. And when we do so, we are then left with a numerator of 6b squared and a denominator of a to the 5th. Now, even though we won't always write it this way, this is really what's going on. We're dividing both the numerator and the denominator by the same thing. And whenever you divide by something over itself, we're really dividing by 1. And whenever you divide by 1, the value of what you get is equivalent to what you started with. So, I've rewritten that here. Basically, you're actually dividing both the numerator and denominator by common factors. In this first problem, do not start going cancel happy here. Instead, factor out the numerator. Notice that you have 5 times x plus 2 over x plus 2. And it's these common factors of x plus 2 that will cancel each other out and leave you just with 5. Now the key phrase for this whole section is factor and cancel, because you're going to have your factoring skills down in peak form to be able to master this section. For this next problem, do not start canceling x squareds. You cannot cancel things that are not factors. So we factor the numerator into x minus 8 times x plus 4. We factor the denominator into x minus 8 times x plus 8. Then we see that we've got common factors of x minus 8, which can be divided out of both the numerator and the denominator, leaving us with x plus 4 over x plus 8. Do not cancel x's, do not cancel 4 and 8. Terms that are in addition and subtraction problems are not cancelable. You can only cancel factors, those terms that are in a multiplication problem. In problem number 5 here, let's factor the numerator. I see that 6 and p is the GCF, and dividing it out, I'm left with p plus 2. Likewise, down below, I can factor out a 2p and be left with q minus 2. So when I go to cancel, I can divide a p out of both the numerator and the denominator, and I can divide the 2 and the 6 by 2 to leave 3 and 1. And so what I have here now is 3 times p plus 2 over q minus 2. Now I can leave my answer in that form right there, or I have an option. I can do the distribution and put it back to the form 3p plus 6 over q minus 2. Which one is preferred? That depends upon your teacher. Usually we go with the factored form. Even though it's not more simplified having this parentheses here, we can see that there will not be any more cancellation possible. If we leave it in this form that's distributed out, we technically, in order to check if it can be reduced, would have to factor it and then do the canceling or check to see if it will cancel. So it's just generally a better idea to leave the numerator factored in your solution. The -1 technique basically says that anytime you have a minus b divided by b minus a, that will equal -1. Now let's take a look at why. You know that subtraction is not commutative. If you have 7 minus 9, that equals -2, but 9 minus 7 is equal to +2. You do not get the same answer when you change the order of subtraction, but you do get the same value of 2, just the signs are opposite. Likewise, when you have 14 minus 5 and 5 minus 14, the first one gives you 9, the second one gives you negative 9. Same number when you consider their absolute value, but different signs. Well, the same thing's going to happen with a minus b and b minus a. We don't know what the values of a and b are, but we do know they will be opposite in sign. So you can cancel the numbers, leaving just the negative 1 left over. Now, how do we put that into practical terms? In number 6, we can see directly I've got an a minus b over a b minus a. We can just say this is equal to negative 1. If you want to think of this as crossing them off and making one a negative 1 and the other one a positive 1, that works fine also. In the problem after it, we would factor the numerator into 4 plus x times 4 minus x over x minus 4, and notice that we've got this a minus b, b minus a pattern with the x minus 4 and 4 minus x, leaving just the 4 plus x. Now, how do you write this as a solution, and where do you put the negative? You can either say negative 1 times, and I'll write that as x plus 4, as one possibility. You also have the option of writing negative 1 times the 4 plus x, as I originally could have had. I also could do some distribution and write that as negative x minus 4. Which one is better? There is no best form. I probably would go with the third form there personally, but that's kind of up to you. Okay, let's look at this next problem. The numerator is going to factor into 7 plus x times 7 minus x. Do not reverse that. You cannot change the order of subtraction. You got to leave it as is. The denominator will factor into x minus 3 times x minus 7, and you can see that I've got this a minus b, b minus a pattern. So I'm going to put that negative 1 right there. Now, some people prefer to put a negative in front of the fraction like that and write this as x plus 7 over x minus 3. I'm okay with that, but you just got to be careful that you don't lose that negative blending into the division bar. What I like to do is move my negative to be with the numerator, but I can't just write it with the x. It actually applies to the entire numerator, so I'd have to change that to a negative x minus 7. This is a common error-prone place, so you've got to be very careful with your negatives, especially when there's a binomial in the numerator, how you write it, because if you just move that up a little bit, it appears it goes only with the x and not with the 7. So be very careful in how you approach this. In number 9, I notice that my denominator will factor. I can divide out of 5 and be left with 4a minus 5. Now, when I go to cancel my 5's, don't just say, oh, my answer is 4a minus 5. That's wrong. Sometimes we get lazy when you don't put these little 1's there, but technically that 4a minus 5 belongs in the denominator, and you need that 1 as a placeholder up in the numerator to make sure that that 4a minus 5 stays in the denominator. For this next problem, the numerator normally we can't do the sum of two squares there, but I can factor out of 4 and have t squared plus 4 left over. And now I have the difference of two squares down below, and I can write this as t squared plus 4 times t squared minus 4. Now, these t squared plus 4's are going to cancel out right off the bat there, and we have a choice on how we write our answer. We can either go 4 over t squared minus 4 and know that we can't do any factoring or canceling, or we can leave the 4 upstairs and we can factor the denominator into t plus 2 times t minus 2. So you really have two choices on the format for the solution here. If you can spot ahead of time that after you factor it there won't be any canceling possible, you can just leave it here. Some people just like to factor it all the way and verify that there's no cancellation possible.